Hello everyone, welcome to my channel. In this video, we will discuss second chapter polynomials problems. Let's see the example first. So example 1. Look at the graph in figure 2.9 given below. Each is the graph of y is equals to p of x, where p of x is a polynomial for each of the graphs. Find the number of zeros of p of x. So we know that the point where the graph touches the x-axis, the x-coordinate of the point where the graph touches the x-axis is the 0 of the polynomial. So let's see at how many places the graph touches the x-axis. If you see the first problem, first graph, here the graph is touching the x-axis at only one point. So therefore this graph will have only 1 0. So the first graph will have only 1 0 because the graph is touching the x-axis at only one point. And if you see the second graph, the graph is touching the x-axis at 2 points. So therefore it will have two different zeros. Next, third graph. So the graph is touching the x-axis at three different places. So here and here and here. So therefore it will have three different zeros. Next, graph number 4. The straight line is touching the x-axis at only one point, therefore it will have only 1 0. So this one. Next, fifth graph. So the graph is touching the x-axis at two different places. So it looks like that it is touching the x-axis at only one point, but it is touching the x-axis at two different places. So therefore it will have two different zeros. Both are positive. And if you see the next graph, it is touching the x-axis at how many places? 1 2 3 4. So the graph is touching the x-axis at 4 places, therefore it will have 4 different zeros. Now let's see exercise first problems. What is the question? Exercise first 2.1. The graph y is equals to p of x are given below. For some polynomial p of x, find the number of zeros of p of x in each case. So the same way of example 1. So how we found the number of zeros of in example 1, the same way, right? Let's see the problem first graph. So this straight line is a line parallel to x-axis. It is not touching the x-axis, so therefore no zeros. So number of zeros are 0, means no 0. Next, let's see the second. The graph is touching the x-axis at only one point, so therefore it will have only 1 0. Next, third graph. The graph is touching the x-axis at three different places. So here negative x-axis and positive x-axis 2 times. Total 3 zeros. Next, fourth graph. In the fourth graph, the graph is touching the x-axis at two different places on negative x-axis. So therefore it will have two different zeros. Next, fifth graph. The graph is touching the x-axis at how many places? 1 2 3 4. 4 places. So therefore it will have 4 zeros. Next, sixth one. The graph is touching the x-axis at how many places? 1 2 3. So it will have So let us zoom it. Yes, 3 zeros. Now let us see example 1. So what is, sorry, example 2. What is example 2? Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and coefficients. So first of all, we have to find the zeros of this polynomial, and then we have to verify the relationship between the zeros and coefficients. So let's write what is given. What is the polynomial? The polynomial is p of x is equals to x square plus 7x plus 10. So let us compare this one with a general quadratic polynomial. What is the general quadratic polynomial? Ax square plus bx plus c. If you compare with the general quadratic polynomial, the coefficient of x square here is 1. So therefore, this a is equals to 1 and b is equals to coefficient of x. B is equals to 7. B is equals to constant term 10. C is equals to 10. P of x is equals to x square plus 7x plus 10. So as we are finding the zeros of the polynomial, let's take p of x is equals to 0. So 0 is equals to, so we have to multiply the coefficient of x square and constant term 10. So 1 into 10 is equals to 10. The factors of 10 must be such that if we multiply, we should get plus 10, and if we add, we should get middle term 7. What are the suitable factors? 5 into 10, sorry, 5 into 2 is 10, and upon addition 5 plus 2 is equals to 7. The suitable factors are plus 5 and plus 2. So let us rewrite the middle term. X square, 7x can be written as 5x plus 2x plus 10. So 0 is equals to, so from the first two terms, let's take x common. Let's take first x common from the first two terms. If you take x common from the first term, we will have one more x, and if you take x common from the second term, we will have 5, and take 2 common from the next two terms, third term and fourth term. If you take 2 common from the third term, we will have x. If you take 2 common from the fourth term, we will have 5. So again take x plus 5 common from the two terms, x plus 5 and x plus 5. Take x plus 5 common, so x plus 5 of, if you take x plus 5 common from the first term, we will have x. If you take x plus 5 common from the second term, we will have 2 equal to 0. That means product of these two factors will be equal to 0. That means any one of these will be equals to 0. So we don't know which will be equal to 0. So that is why we will take x plus 5 equals to 0 or x plus 2 is equals to 0. We will get x is equals to minus 5 and send plus to the right side becomes x is equals to minus 2. So here the first 0 is alpha, right? Let us think first 0, let alpha is equals to minus 5 first 0 and beta is equals to second 0 minus 2. So we have to verify the relationship between the zeros and coefficient. First relation is sum of the zeros. What is the sum of the zeros formula? Alpha plus beta must be equals to b by a. So let's check. Let's take alpha plus beta. What is alpha plus beta? Minus 5 plus minus 2. Minus 5 plus minus 2 is minus 7. Now let's check the value of minus b by a. So what is the b value? So here b value is 7, b value is 7 and a value is 1, 7 by 1. So minus b by a, right? Minus b is 7, a is 1, minus 7 by 1 will be equals to minus 7. So alpha plus beta is minus 7, minus b by a is also minus 7. So therefore alpha plus beta is equals to minus b by a. So the first relation has been verified. Now let's verify the second relation. What is the second relation? Product of zeros alpha plus beta must be equals to c by a. First let's take alpha into beta. Alpha into beta. So alpha is minus 5, beta is minus 2. So minus 5 into minus 2 is equals to plus 10. Next let's take c by a. What is the c value? A value is 1, right? Let's see, wait, what is the c value? Yes, c value is 10. So c by a means 10 by 1, which is equals to 10. So alpha into beta is 10, c by a is also 10. So therefore we can say that alpha into beta is equals to c by a. So the second relationship is also verified, hence verified. Next, example 3. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and coefficients. The same way as we have done in example 2. So what is the polynomial? The polynomial given is p of x is equals to x square minus 3. So let's compare this x square with x square minus 3 with general quadratic polynomial. What is the general quadratic polynomial? Ax square plus bx plus c. So if you compare with this general quadratic polynomial, a, which is the coefficient of x square, here coefficient of x square is 1, so therefore a is equals to 1, and b, the coefficient of x, there is no x term here, right? So therefore coefficient of x is 0, so b is equals to 0. And c, constant term, here the constant term is -3, so c is equals to -3. So first of all, let's find the zeros. P of x is equals to x squared minus 3. So let's take P of x value 0 as we are finding the zeros. So 0 is equals to x squared minus 3. Bring minus 3 to the left side. So 3 will be equals to x squared. Otherwise we can write it as x squared is equals to plus 3. X is equals to plus or minus root 3. Why plus or minus root 3? Because plus root 3 whole square is plus 3, minus root 3 whole square is also plus 3. Minus into minus plus, root 3 into root 3 is plus 3. So that is why x is equals to plus or minus root 3. That means first 0 is plus root 3 and second 0 is minus root 3. Now let's verify the relationship between the zeros and coefficients. First relation is sum of the zeros. Alpha plus beta must equals to minus b by a. Let's take alpha plus beta. Here alpha is plus root 3 plus beta is minus root 3. Plus root 3 plus minus root 3 is 0. So alpha plus beta is 0. Now let's take minus b by a. Minus coefficient of b is 0, right? 0 by a value is 1. So minus 0 by 1 is 0. So therefore alpha plus beta is 0. Minus b by a is also 0. So therefore we can say that alpha plus beta is equals to minus b by a. So the first relationship has been verified. Now second relationship, product of zeros alpha into beta must equals to c by a. So what is alpha? Root 3 plus root 3 into plus root 3 into minus root 3. So there is only one minus, right? Plus into here, this is plus, plus into minus minus. Root 3 into root 3 is 3. So product of zeros is equals to minus 3 and c by a value. So we know that c is minus 3, a value is 1. So minus 3 by 1 is minus 3. So product of zeros is equals to minus 3, c by is also minus 3. So therefore alpha into beta is equals to c by a. The second relationship has been verified, hence verified. Next example 4. Find quadratic polynomial, the sum and product of whose zeros are minus 3 and plus 2. Here sum of the zeros is minus 3 and product of zeros is plus 2. So we have to find the quadratic polynomial. So let alpha and beta are the zeros of the polynomial. Let alpha and beta are the zeros of quadratic polynomial. So what is given? Sum of the zeros, right? Alpha plus beta is equals to minus 3 and product of zeros alpha into beta is equals to 2. So we have to find the quartic polynomial. So what is the formula to find the quartic polynomial? P of x is equals to k of x square minus x of sum of the zeros alpha plus beta plus product of zeros alpha into beta. So let's k of k is some constant x square minus x of alpha plus beta. What is alpha plus beta is already given, it is minus 3, plus alpha into beta, it is already given 2. So k of x square minus x into minus 3 minus 6 into minus 3 is plus 3x plus 2. Here we did not get any denominator, right? So denominator is only 1. So therefore if k is equals to 1, p of x is equals to x square plus 3x plus 2 if constant k is equals to 1. So this is the quartic polynomial with the given sum of the zeros and product of zeros.